Welcome to Bahamian Mathematics. To see more videos like this, subscribe, like, and share. In today's video, we will learn how to calculate the value of pi along with the circumference. Let's take a look. First, let's review the definition of circumference. Circumference has to do with the circle, and it is the total distance around the circle. If we started at one point and went all the way around until we came back to where we started, that distance is called the circumference. Now, unlike a straight line, if we used a ruler, we would be unable to calculate the length of the circumference because it is not a straight line. And so this gives us a problem now. How do we calculate, if we're given a circle, the length of the circumference, the distance from one point all the way around to where we started? How do we know how long that is? Well, before we do that, let's take a look at the diameter. Remember, the diameter is a special chord that passes through the center of the circle and it touches the circumference at 2 points. So this is a diameter. Now, is there a relationship between the circumference and the diameter? Let's have a look. Here's the circumference, and in that same circle, here's the diameter, both represented by red. If we take a look at this table, we have 3 examples of different circles of different sizes with different diameters and their circumference. So in the first circle, we have the diameter of 10 centimeters, and that circle has a circumference of 31 centimeters. In the second circle, the diameter is 3 inches and its circumference is 9 inches. And in the third circle, the diameter is 5 feet and its circumference is 15.5 feet. Can you establish some type of relationship between the diameter and the circumference based on these measurements? Well, if we look and we say 10 times 3 equals 30, 30 is close to 31. And if we take 3 inches and multiply it by 3, we get 9, which is exactly the circumference of that circle. And if we take 5 and multiply it by 3, we get 15, which is almost 15.5. So in every case, when we multiplied by 3, when we tripled the diameter, it gave us a measurement very close to the length of the circumference. And so if you look, each one was multiplied by 3. Each diameter we took and started with, when we multiplied it by 3, it gave us a length of the circumference that was very close. And so what this means is if we took the diameter of the circle 1, 2, 3 times and we wrapped it around the circumference, it would almost meet up to where we started, and there would be a little space that would be left. The circumference is a little bit more than 3 times the diameter. There's a little piece that's left, which means the circumference is a little bigger or a little longer than 3 times the diameter. And so let's look at the relationship again. Here's the diameter of the circle, and we can use a ruler to measure the diameter of the circle. When we multiply that by 3, the distance that we get almost completes the circumference, which means we need a little more than 3 times the diameter to give us the circumference. And so let's see some actual measurements. We will look at the ratio of the circumference to the diameter. And so this simply means that we will take the circumference and we will divide it by the diameter. So let's take a look at a 9-inch wheel and let's measure the diameter. The diameter is 9 inches, and when we find the circumference, it's 28.285 inches. And if we plug those measurements into the ratio above, and we say the circumference is 28.285, and we divide that by d, which is the diameter, which is 9 in this case, we end up with a number 3.142777. Let's remember that as we look at a few more examples. Again, if we look at the diameter and the circumference, and we find the ratio of the circumference to the diameter, so c divided by d. In this case now we will look at a clock. We have measured the clock's diameter to be 14 inches, and we know that the circumference is 44 inches. When we divide c, which is 44, by d, which is 14, we get a number 3.14285. If you remember in the last example, it was also 3 point something. Let's look at one more. Again, we look at the diameter and the circumference and see how they are related. We will look at the ratio of the circumference to the diameter, C divided by D. If we take a 5 centimeter candy, we measure the diameter and know that it's 5 centimeters. And we know that the circumference is 15.7075 inches. When we divide C, which is 15.7075, by D, which is 5, we get 3.1415. So let's take a look at those measurements just now. Every time we divided the circumference, when we started with the circumference, and we divided it by the diameter, we got these numbers, 3.142777, 3.14285, and 3.1415. As you can see, they are very similar. They all start 3.14. Some have 2 and some have 1 after that. This is a special number called pi. So this ratio is pi. And it is a Greek letter of the alphabet. It's the 16th letter in the Greek alphabet. And it is the ratio of the circumference to the diameter. So even though pi ends up being a number, pi is actually a ratio. It's the ratio of the circumference. We start off with the circumference and we divide it by the diameter. And this always gives us the same or similar number, and we call that number pi. We often estimate pi to 22/7. So let's try to divide 22 by 7 to see what decimal number we come out with. Let's put up the numbers first in the questions before so we can see what answers we got. And we note that pi is called an irrational number. And so let's start with 22 and divide by 7. 7 into 22 goes 3 times. 3 times 7 is 21. When we subtract, we get 1. And now we have to put decimal points and bring down the 0. 7 into 10 goes 1. 7 by 1 is 7. When we subtract, we get 3. And again, we have to bring down 0. 7 into 30 goes 4 times. 7 times 4 is 28. And we subtract. And we have 2. And we bring down a 0. And if you look at the answers in red, and you look at the division answer above, you can see that they are very similar. And so every time we divide 22 by 7, we come very close to the value of pi, and this is why it is used often as an estimation for pi. And no matter how far we continue to go with this division problem, the numbers will never stop, and they will never repeat. And these numbers will go on and on forever. And let's take a look now at the first 100 digits of pi. You can see 3.1415926535 and so on. These are the first 100 digits of pi. Let's take a look at the first 200 digits of pi. You'll notice that they keep going on and on and on, and they never stop, and the digits don't ever repeat sufficiently enough to provide a pattern. Just in case you don't believe me, here are the first 500 digits of pi. And as a matter of fact, computers have been used to generate millions of digits of pi, and they have not stopped yet. And so we remember that pi is a ratio of the circumference to the diameter. It is estimated at 22/7, but it is often stated as 3.14 or 3.142. So let's take a look at the formula now for the circumference. We know that the circumference is about 3 times as big as the diameter, and we know pi is the ratio of the circumference to the diameter. So let's take the formula for pi and see if we can figure out the formula for the circumference. Pi equals c, circumference, divided by the diameter. We've seen this in the previous slides. And another way to write that is pi equals c over d. The line in between means divide. Now, what if we wanted to isolate c, or the circumference, and make c the subject of the equation? Well, the easiest thing to do is to multiply both sides by the diameter. And we know when we do this, d cancels with d. d into d goes once, d into d goes once, and they cancel. But whatever we do to the right side, we have to do to the left-hand side to keep it in balance. And so we have to multiply pi by d also. And so now what do we have? We have c by itself on the right-hand side is equal to pi d. pi times d is the same as pi d. And if we rewrote it in a way that looks nice to us, we would say c equals pi d, or c is equal to pi times d. And so we've found the formula now for circumference. C is equal to pi multiplied by d. And so in order to find the circumference, we need to know the diameter and the value of pi. And so let's pretend in this question pi is equal to 3.14. You will be given that information. And d is equal to 4 centimeters. You will also be given that information. And so all we do is we substitute the values of pi and d into the equation. And so c is equal to pi, well, we know pi is 3.14, multiplied by d in this case is 4. And so when we use our multiplication, or our calculator in this case, we can put in 3.14 multiplied by 4, and we get 12.56 centimeters. You always have to put the units at the end as well. So in a circle that has a diameter of 4 centimeters, the circumference, if you measured it, would end up being 12.56 centimeters. Now let's take a look at another scenario. We know that c equals pi d. That's a formula we have established. If we expand this, we get c equals to pi times. Now what would happen if we did not have the diameter, but rather we had the radius? Well, we know that the diameter is equal to 2 times the radius. And here's the radius, but here is the radius also. So instead of writing d, we can replace d with 2r, because the diameter is equal to 2 radii. And we can rewrite 2r as 2 times r. And so we have another formula. Instead of c equals pi d, when we're given the diameter in the equation, if we're given the radius in the equation, we can use c equals 2 pi r. So let's take a look at an example with this. If we are given pi as 22/7, and the radius in this circle is 7 millimeters, we can say c equals 2 times pi in this question is 22/7, multiplied by r in this question is 7. And since we have fractions, and we see a 7 in the denominator and a 7 above the denominator, we can cancel the 7s. 7 to 7 goes once, 7 to 7 goes once. They cancel each other, and we're left with 2 times 22, which is 44. If we check our calculator, 2 multiplied by 22 divided by 7 times 7, we get 44. And we can't forget the units, millimeters. For a circle that has a radius of 7 millimeters, it has a circumference of 44 millimeters. And now it's quiz time. Find the circumference in a circle that has 6 centimeter radius. Time's up. The answer is 36 centimeters. We know c equals 2 pi r, and so c equals 2 times 3, pi is 3, multiplied by r, which is 6. 2 times 3 times 6 is 36. Question 2. Find the circumference in this circle. Time's up. In this case, the circle has a diameter of 10 centimeters, and so the answer is 31.4. C equals pi d. We know pi is 3.14, and d is 10. So 34 times 10 just means we move the decimal point one place to the right, and we get 31.4 centimeters. Question 3. Find the circumference 4 centimeter radius. Time's up. The answer is 24.8. C equals 2 pi r in this case because we're given a radius. And we know that 2 times 3.1 is 6.2 times 4 is 24.8. And the last question, find the circumference, 21 inches diameter. Time's up. The answer is 66 inches. If c equals pi d, then C equals 22 over 7 times 21. We can see that 7 and 21 are in the 7 times table. And so 7 into 7 goes once, and 7 into 21 goes 3 times. 22 times 3 is 66. And now you've solved the mystery of calculating pi and circumference. Well done.